Welcome back, class. I'm Mr. Teacher with the SAT Math video guide. Last time we actually went a little bit over 15 minutes and it was exceptionally long. We're going to continue on number 10 of section 8, test 1. So, if k equals to x over 3 and x is not equal to 0, then what does 3x equal in terms of k? So first we need to solve for x. So x over 3 is equal to k. We cross multiply the 3 to this side. So x equals to 3k. Now we just need to multiply x by 3. So if we multiply x by 3, we need to multiply 3k by 3 also. So 3 times x is equal to 3 times 3k. So 3x is equal to 3 times 3 is 9, 9k. 9k is choice B. So let's go to number 11. Oh, there we go. Number 11, a cube has two faces painted black and the remaining faces painted white. The total area of the white faces is 64 square inches. What is the volume of the cube in cubic inches? So 2 of the faces are black and 4 of the faces are white. And these are white. So 2 are black, 4 are white. And the area of all of these 4 faces adds up to 64. So we need to find the area of one square, one face. So that's going to be, since there are 4 faces. So just one of these white face blocks is going to be equal to 64 divided by 4, which is equal to 16. And since these are squares, because it said it's a cube, we know that the sides are just going to be the square root of 16. So the square root of 16 is the length of one side, which is equal to 4. So each side is 4. Each side, every single side in this entire cube is going to be 4. So something like this. It's going to be 4, 4, and 4. So the volume will be 4 times 4 times 4, or 4 cubed, which is equal to 64. That is choice A. So there we go. Now we do number 12, and I have to draw a number line. Very long one. No, that's very slanted. Let's try and make it a bit more straight. Yes. Okay. So this point is 0, and then this is 1, and this is x. This is nothing. This is, well, that's something. It's not a variable. This is y. And then again over here up to -1. Down to -1, I should say. -1. And this one doesn't have a variable. This is w. And that is v. Okay. So the letters V, W, X, and Y represent numbers as shown on the number line above. Which of the following expressions has the least value? So we need to find the values of each one of the variables to even start working on this problem. So from 0 to 1, it took 4 steps. So if it took 4 steps from 0 to 1, which is 1, each step is 1 divided by 4, so it's 0.25 a jump each time. On this side too, because the scale didn't change. So x is equal to 0.25, that's 0.5. Y is equal to 0.75, that's 1. This is equal to 0.25. W is equal to, well, not 0.25, negative 0.25. W is equal to negative 0.5. V is equal to negative 0.75. And this is just negative 1. So which of the following expressions has the least value? So let's start. Okay, so A says V plus Y. So what's V plus Y? It's 0.75 plus minus 0.75, and the plus and minus turn out to be a minus, cancel out each other and turn into a minus, so that's just equal to 0. So okay, so that's not positive nor negative, so we can keep that. Choice B is V plus X, and V is negative 0.75 plus X, which is just 0.25. This equals to minus 0.5, and this seems very likely for the correct answer because it's very negative V. Choice E says W plus X. Well, W is negative 0.5, so negative 0.5 plus 0.25, and that's just equal to negative 0.25. So we can cross this off right now. We can cross off A and C because we've already found a lower value, so A and C is crossed off. So the rest ones are D. D is V minus W. V minus W is negative 0.75 minus negative 0.5, so these cancel out and turn into a plus. So negative 0.75 plus 0.5, it equals to negative 0.25. So we can cross this one off too, because there's already a negative 0.5. And finally, choice E, just to make sure, Y minus X. Y is 0.75 and X is 0.25. So 0.75 minus 0.25, which is equal to 0.5. And since that's not even the lowest value, that's the highest value, but we're looking for the lowest value, so this is crossed off. Our only answer left is choice B. So we just need to solve each one of the equations to make sure, because in this problem the answer choices aren't put in order. Like, general rule is that in any SAT math problem, the answers are written down in order of value, but these are never written in order of value, because if they were, you could just start with C, and if it was high or low, you could pick accordingly and start working the others out. So now let's go to number 13. So there are a set of numbers here: 3, 4, 6, 7, 10, 12. This looks like a median problem. The number n is added to the list above, so number n is just gonna be anywhere over here. So if n is an integer, so it's not a decimal, if it's an integer, which of the following could be the median of the new list of 7 numbers? So median, one rule about median is whenever you're trying to find the median of an odd number of numbers, so like a set of 5 or a set of 7 or a set of 9, the median is going to be easy to find because it's going to be the middle number. So if it's 5, the median is term number 3. So likewise, let's say n was added to the beginning. So it's n, 3, 4, and here, 6. So 6 is the middle number here. So 6. That's a possible idea. So choice 1 is 6, so that's correct. Choice 2 is 6.5, and that is never going to be correct in an odd number set of numbers, because whenever there's an odd number set, the median will always be a number within the set, no matter what. It's not going to be a number outside. So that's automatically cut off. And choice 3 is 7. Well, it could be 7 if this n wasn't here and it was added over here. Then there's 1, 2, 3, 4. Then 7 becomes a new median, so that's correct. So choices 1 and 3 are correct, which is choice D. So I'll try and squeeze in another problem right now. Okay, number 14. It says, okay, no, it doesn't say yet. Let's draw this diagram. So it looks kind of like a basketball with just 2 markings. Okay, so this is gonna be color 1. So is this. So they're gonna be the same color. And this is gonna be color 2. So, as shown above, a certain design is to be painted using 2 different colors. So from right there we know that color 1 and color 2 are never going to be the same. Okay, so if 5 different colors are available for the design, how many differently painted designs are possible? Well, we can use the counting principle here. So let's say color 1 has 5 choices. So this is also 5 choices, but we don't need to remember that because it's just color 1. And color 2 will be 4 choices because the numbers have to be different. And since one of the numbers is used in color 1, that can't be used in number 2, so there's 4. So the number of possible combinations is 5 times 4, which is 20. That's choice B. And I will be finishing off for now. We'll do the last 2 problems in the next video. I hope this helped you in your SAT math prep, and I will be talking to you guys later.